started to understand why it was important to retire old systems and why it mattered to bring data forward. It was killing them, and they could not understand it because no one had ever brought it forward. Now, you can have this conversation with a leader. To Suresh's ant analogy, that's one-on-one. It doesn't change the culture. You can have a champion in the culture. One-on-one, it's not going to change it. You've got to be able to bring data forward that can actually change the organization. I'll just go brush through this slide very quickly because I felt so passionately about it. But these are some tips for working within large organizations and for both sides. If you're a pioneer or a manager, you got to recognize some of these things. Won't dwell on that. For data and analytics, we felt bringing forward a lot of the opportunities. You see a lot of this stuff right here in this discussion. Even within these opportunities, data is the great issue. You want to write an AI, it's a sea creature that lives in an ocean of data. If you don't have it, it's not going to work. And the data quality has to be relatively high. If you've been listening to any of these sessions you've had, you've heard some of that. As VCs, don't come to us and tell us, I've got this cool application that's going to replace radiologists, unless you have a source for that data. Because we're not stupid, guys.
Yeah.
So, understand that. Now, just as an example, I see a lot of healthcare examples. Actually, I was listening to the guy this morning as the keynote where he talked about healthcare data matching. I actually did healthcare data analysis in New Zealand with the Ministry of Health there. And because there was a national ID, we were able to go through and prove you could improve post-surgical outcomes by actually having the patient leave earlier. Hospitals are not nice places. You pick up diseases, things accidentally happen to you.
There's sick people there.
Yeah, it's not a place of wellness, as a surgeon said to me. In fact, the reason we started the study was I was walking down the hallway of the hospital with the surgeon, and I dropped a candy bar I just bought. And I reached down for it, and he said, "Don't pick that up."
Yeah.
Was it in the wrap?
It was still in the wrapper.
Yeah.
Yeah, he didn't care.
Yeah.
As far as he was concerned, that was now contaminated. Infections are rampant in hospitals, and they're generally disease resistant because that's what lives there. So if they can get you, we were able to first validate that assumption that patients that left earlier as a trend tended to achieve better outcomes. Then we instituted a protocol and changed it so that it included a voluntary program for early discharge and some take-home care with training, and then we validated that it worked by being able to go back into the data and prove this. The result was a much lower cost for the treatment, for the patient care, and we were able to do it in such a way that it was actually presented as a paper to the New Zealand Medical Association. Again, the point is data used to prove applied value. Make a value equation and you've got a business. Don't make it, you've got a fantasy.
And the opportunities to innovate and invest, they lie right across every aspect of it. You know, people think big data analytics means you have to only play around with, algorithms. No, it is not so. Right from think of it this way, the genesis of information, from the time you think how it gets transmitted or it is sensed or picked up, how do you transmit it, the cost of communications. Praveen just talked about, he comes from Verizon. I mean, I'm telling you, half the applications fall flat because the cost of communication is so high. You may have the smartest of the sensors, who cares? So think of it that way. How do you store it? Is it continuous data, sparse data, discrete data? Think about it. Big data, I think it is misleading many a times. I think the right word is right data.
Yeah.
It could be small, it could be big, I don't care. That's a function of computing power, right? Does it add value? Does it fit into my value creation equation or not? That's important. So similarly, search engines, security of the data. Security is a problem that is never going to get solved. It is always a moving target. I mean, think of it this way. The banking industry was, I think, created by Medici family in 14th century. Till today, banks get robbed. So the security problem is never going to get solved. So you have to keep advancing. There is an opportunity to innovate all the time. tagging, mapping, statistics, analysis, engines, and then how do you visualize, how do you communicate? I mean, I think this is an exciting world we live in. There is so much to do. That's why we went agnostic. We said, look, we're not going to be technology specific. Hey, do I invest into mobile? Of course we do, as long as it transforms the industry, as long as it creates more value to it. We went industry agnostic. I mean, this cell phone, what is it? Is it a consumer electronics industry? Is it a photography industry? Is it a music industry? What is it? Is it a communication industry? It's all of it.
Everything, yeah.
So
Yes,
I think it is time that even the investment community needs to look at it as a different equation. You can't afford to live with a model where 8, 9 out of 10 fail. I think you are creating less value and destroying more value of the society. Right? One more example, and this also is our hands-on example from our own experience. Typically, if you are in a product business, over a period of time, products get commoditized and they would get replaced. So the thing is, once again, you need to keep revisiting your business model and say, hey, how can I create more value out of it? So here we had an actually $8 billion power plant business way back in late 90s, where you were generating electricity. And a company like, for example, Siemens, GE, or ABB, they make power plants and then they sell it to utilities who operate them and sell electricity. So utilities, their core competency is to deliver electricity to you, let your meter run, they bill you, you pay. That's their core competency. Company like GE, Siemens and all, they make power plant and sell that as a product in those days. What we thought was, hey, how can we change the revenue streams? How can we get more value out of it? How can we create more value for the customers? So what we did was we looked at the whole situation. There were 60,000 power plants in the world, 20,000 of them in USA, 1/3 almost. And then each power plant lasts a long time, 30 years, 40 years or so. So they undergo a change of configuration over a period of time, performance over a period of time. So if you could digitize the life cycle of a power plant, if you could monitor what happened in the beginning of day one, and then 3 years, and 6 years, and so on and so forth, maybe you can get more out of it. So as a result of that, we basically told the utilities that, look, we designed it, we engineered it, we installed it. Why don't you give this responsibility to me to maintain and operate it? Give me a long-term contract. I will make sure that you get the same megawatts. I'll make sure that you have the same reliability, uptime. As long as, hey, you get the same what you are getting from your own people, what's the problem? And guess what? We will do it for 10% lower cost. Wow. So if I'm a utility CEO, if I'm PG&E or if I'm Duke Energy or Florida Power and Light, I would be happy, right? And that's what happened. So we basically started getting long-term service contracts, and we used that window to enhance the performance of the power plants. We were able to get more megawatts out of it, maybe improve availability of the power plants, and we split the profits of that additional benefit that we were able to provide to utility, to our customers eventually. And as a result of that, I think the company landed up acquiring almost 65% of the power plants in USA. Long-term service contracts for most of them 12 years, 6 years, 18 years, that long. And those contracts' value was, guess what? $32 billion annuity. So humongous business. Where is a product business of $8 billion? And in the next 5 years, it becomes a pretty, grows up multiple times. So I think if you keep your mind grounded around value creation, we are talking today, day and night we are talking about blockchain, blockchain, blockchain. But I think I go back to the fundamentals. Fundamentals are, am I able to create more value from a process or an activity that I do using blockchain or not? If I can, worth doing it. If I can't, then maybe my good old stick is fine. I could be doing a very primitive stuff, and that's still a good business. So with that, let's move on to a quick comment on sensors, because we are talking about sensors. We tend to forget that today sensors have become pretty affordable. They become cheap, they become very reliable. It has taken a long time to get to this situation. However, these are the sensors which were designed and engineered to check the condition of a system. Temperature, pressure, location, this, that, right? But if you want to check condition of a system, these are very good sensors, cheap, low cost, affordable, easy to install, get the information out. But if you want to create new revenue streams, you should be thinking of what's the information that I really want to sense. And I think there is a huge potential today to integrate multiple sensory inputs, design new sensors which could pick up multiple threads of information, because that would create new revenue streams, new value streams. And I think that was the idea of putting this slide together. And one of the reasons why many of the new systems don't work, because they are leveraging the old sensors. But if your input is limited, then the output is going to be limited too. Then the only thing that you can do is statistical analysis and pattern recognition, but that has an inherent limitation of not being able to capture the physics of the system, the chemistry of the system, and the underlying constitutional relationships, the interdependence, interrelationship. They don't capture it. So you're playing it to a very narrow field. So think about it, broaden the scope of it, and I think there will be more to it. So many into one, I think is a huge play. Next one?
But just before we go off this one, I want to mention one
Yes,
thing.
please.
For smart sensors, in fact, any of the full business process, a lot of the monitoring that we talked about was on the turbine island. It was monitoring a device. You're going to have to create value. You're going to have to go bigger than that. You're going to have to monitor the full business process. You'll see a lot of stuff that GE did for digital twins and all this other stuff. It actually ends at the turbine island. Outside of that, a power plant is made by 100 vendors, maybe even 1,000, who knows? You're going to have to be able to monitor more than a single piece of the spectrum. You've got to monitor the whole thing. And secondly, security and bandwidth matter. They do not generally park power plants right next to big internet pipelines. And equally, you may not have the ability to handle that kind of data. Even for a fairly simple power plant, you can have 30 or 40,000 data points coming in at hertz resolution. So 1 per second. You're storing that. Seems like a great idea, but pretty soon you are paying a fortune for storage. So be intelligent about how you look at that. Third point, and I'll move on, security. It's power plant data, folks. China doesn't allow it to be exported from China. Saudi Arabia doesn't allow it to be exported from Saudi Arabia. South Korea doesn't allow it to be exported from South Korea. And the US doesn't allow it to be uncontrolled. NERC-CIP regulations require that it be carefully managed. So don't walk into this telling people you're going to manage a value unless you've thought about those things.
Yeah, sure.
How you define smart sensor means how you distinguish smart sensor from conventional sensors.
So think of it this way. I mean, I grew up in aviation in my earlier life. If I'm a fighter pilot, if I'm flying, ideally speaking, I just want 2 gauges in my cockpit. One gauge should tell me everything is okay. The second should tell me eject. You know?
Yeah.
Right? But that doesn't happen. I've got multiple gauges, lights going on, and the firearm, put finger on the trigger, and all that stuff. So the way you design new sensors would be, you go back to the end first. What's the most value you want to get out of this system? So if you are in a business, let's say you own a hospital. What you want is that you decide your priorities, that look, patient should get cured fastest, minimum fatalities, minimum infection. So you prepare a kind of a prioritized list of things that you want out of it at the lowest possible cost, right? Now you say, hey, is my system really capturing this value equation or not? So wherever you see the gap, that's where you say, hey, I need to pick up maybe patient entry, admission, and diagnostic data quickly. I should know that. What were the prescriptions given? Were they delivered rightly? And was the improvement happening? So like that, you would institute the handoffs and the touch points in your system, which may be existing and may not be existing. And those gaps are the ones where you should institute the new sensory integration program. It's just a very simplistic answer to a lot more loaded question, I would imagine. But that's how you go about doing it.
I can give you an easy example of a dumb sensor. Walk into any hospital right now, and particularly in the ICUs or even the regular wards, and you'll constantly hear alarms. They're all over the place, and the nurses ignore them. They ignore them because the alarm has nothing to do with the actual patient's care. A smart sensor understands if the patient is in the bed and doesn't alarm until there's an actual cause to
Yeah.
alarm it.
As my
False
sit-
positives are a horrible, toxic thing because it makes it so people ignore the alarm and they don't know anything really matters. Over alerts.
Yeah.
Yeah.
You see additive manufacturing technology revolutionizing the sensor area in the manufacturing space.
Absolutely.
That's
In fact, the manufacturing technology is already going through a huge transformation in my view. Most of the consumer products, as you know today, they have a propensity for personal taste. Like people want to have a coffee of their choice and tea of their choice, the cup of their choice, because these accessories have become their personal statements in many ways. So there is a lot more demand for, you don't want coffee like Folgers to be shipped to you in containers and delivered to you in big bottles in a big coffee pot anymore. You want a lot more. So consumer products are getting a lot more personalized today. And as a result of that, I would say manufacturing doesn't have to be in a big factory anymore, because a lot more efficiencies can be obtained from the supply chain if I was to make the right amount of stuff for local community. So I think the 3D printing, additive manufacturing would go a long way in what I call as either, you can call it person-centric manufacturing or distributed manufacturing. You could be having in your own subdivision someone, for example, I'll give you two examples. In fact, right now I'm mentoring a girls team who are using 3D printing for making nails. So that what you do is you take your print image is transmitted into a 3D file, and it's basically plastic, right? So it's an easy material to use it right in today's, though you have 95 materials on 3D printing that can be used today. I came from aerospace world myself, worked for 4 years on a NASA project. I used to head the jet engine design program for GE in upstate New York. I can tell you today, why can't you have your personalized nails all the time? You don't have to go to a salon. You could have a printer at home with the right kind of adhesive, and then you could have your nails all the time. Personal jewelry. I know most ladies would not like to wear the same jewelry every time for every occasion. You could accessorize your jewelry. You could accessorize so many things. So I agree with you. I think that is almost like the next frontier. I wouldn't be surprised in a few years' time that all of us have a 3D printer at home, because it will be easy to do so many things. I know there is a friend of mine who works for AT&T. He bought actually a knockdown 3D printer, and he prints the toys for their children every weekend new toys. You know? So I mean, these are easy examples, but you could go a lot more sophisticated with that.
So very quickly, security,
Yep.
it's critically important. We think particularly for the sensors in the industrial space, you're gonna have it. One of the earlier speakers said, build it in. It's absolutely correct. It's gotta be there from the word go.
So-
Just because we're almost to the end here,
Yeah.
this kind of is a summary of some of the learnings we had. I actually threw together this slide. One of the points I wanted to mention on it is the declining technology probably matters as much as the rising. Because one of the better things you can do is to start to eliminate the declining technologies.
Now we want to talk about one example where we are using it as of today. And I think this is important to all of you in the audience here, because what we're doing is we're using the data analytics of the last 25 years to identify patterns for successful startups, successful entrepreneurial ventures. So I started out, as I said, from 97 onwards, and we have been external industry advisor for many, many ecosystems, venture labs, incubators, accelerators, and then did my own startups. And Carl and I, we've been looking at it for past 5 to 6 years, very, very critically. In 2012, I did my first preliminary study of, at that time in USA, there were about 200 incubators and accelerators. Today, there are about 3,000. And you're almost adding almost a new one by the day. So we looked at this whole thing. What is it? Why the failure rates of VC investments are so high? Why 8 or 9 out of 10 fail? What can we do to create more value creation? Once again, more value creation. How can you unlock the potential of so many brilliant minds who are trying to do a startup successfully? So that's the premise. That's what we went about doing it. Here is a snapshot. It is just a capture of the deep data that we have, basically of relating to the 10 cities. There are more than, I think the number is about 550, this is about 7 or 8 months old data. You can imagine there are more than 550 privately funded accelerators today in just these 10 cities. If you go to the tier 3, tier 4, smaller towns, you still find 1 or 2 or 3 in each one of them. You look at the larger universities, each university has 1 or 2 incubators or centers of innovation or entrepreneurship. And we have had a look at almost 50 of them ourselves. We've gone through their curriculum, we have sat in some of those, and we said what works and what doesn't work. What is their market cap? What are the companies that came out of it? What kind of founders did they have? So we tagged all those attributes, and we started to look at what was working, what is not working, how many got funded by the VCs. So with that it's a loaded slide, and obviously I don't want to read it line by line, but these are available to you. Please feel free to look at them critically. If you have any follow-up questions, ask us, not a problem. We'd love to share with you, because I think, as I said right in the beginning, we shared that thought with you. The nature of business fundamentally is collaborative, because collaboration leads to wisdom. Smartness is not enough. So I think with that in mind, let me share this little progression of the 25-year journey, how deep, how the data analytics can lead to a better, superior value creation. When Cold War ended, 8 states in the United States basically founded what is known as the Departments of Economic Development, because it was perceived at that time that it will result into job losses. And therefore, to create new economic growth, we need incubators of new economic growth. And that's how the initial incubators came about. They were state funded. Internet was on the horizon, so software technology parks came about. And as a result of that, initial investments went into buildings where you could be given little subsidized real estate so that you can start a company or do something there. And that continued for next 5, 7, 8 years. Many other states joined in, but we looked at the data and we found that actually that did not really help in their success rate. By merely providing a subsidized real estate, it doesn't really help you, marginally. So by the time, a lot of successful entrepreneurs, they had obviously created hugely big enterprises, and they said, well, let me give it back to the society a little bit. So they founded some new incubator 2.0, accelerators. And they started engaging themselves, mentoring, coaching, and that kind of activity started. When that started happening, you see the advent of some new next generation of accelerators. And you begin to see some higher success rates. You don't do the same blunders that you used to do earlier. And like that, today you're seeing a large number of accelerators where you could see what the success rates are. So we basically distilled all that information and said, look, what are the patterns you find in successful entrepreneurs? What are the patterns you find in your customer discovery? By merely sending a survey and just picking up that customer discovery is not enough. What are the patterns you find in developing a product development, having MVP, early adopters? And at what stage, how much capital would you need to make you successful? So those are the things that we basically learn about. So I know there is there's a lot more to talk and share in this topic, but I think we'll stop there. And but we are available here, and we have our email and phone number here. Please feel free, very open to discuss further, right? And I think we have about 5 or 6, 7 minutes still. So any questions, I would be happy to take. I just realized that this is the only shirt I own. So, but anyway, it is matching with Carl's shirt. I mean, so.
Actually, we're technically out of time.
Right.
So,
Very good. Very good. Very good presentation. All
5
right.
o'clock.
no, 4:50.
4:50. Okay.
Right.